We've only been dealing with math sentence fragments. Here we are, on to full math sentences in the form of equations. And in these last few videos, we've been translating word sentences into number sentences. We have one more word to translate. The word is. That means an equal sign. 4 times a number decreased by 7 is 42. 4 times a number decreased by 7 is 42. And here, this is this equal sign. I mean, if we really want to sell the concept, now that we have the equal sign, let's talk about some properties of it, of equality. Formally, you'll learn these as separate, addition, property of equality, subtraction, property of equality. I just don't want to have to keep writing that over and over again. So the properties of equality, and I'll just do the bullet points for the different operations. So the addition property of equality states that if we have some sort of equality, like this, okay? It can be as gumbly as you want it to be. Basically, what the addition property of equality states is that we can add the same thing to both sides of the equality, and that's fine. We're good. A plus C equals B plus C. The same operation, and then the same stuff, the same constant or expression to both sides of the equation. Now, when we were learning about numbers in grade school, in addition and whatnot, we were always looking for the answer. So, for instance, 5 plus 2 equals, there's a question mark here, or just this, and then we had a little blank for you to put what this was supposed to do. And we were always looking for the answer, but that was everything. And anything different was absurd. It's a change. We're not comfortable with changing something and it being okay. Or at least that was my first reaction to learning these properties, is we're changing the values of both sides of the equation, and that rose a lot of conflict with me, because Oliver, come on, bub. Who's your good boy? So, yes, obviously we're changing what's going on either side, but that doesn't matter. What matters for all of these properties of equality is that the equality is maintained. That's the goal here. Obviously, if we were to just add C to this side, this isn't necessarily the same statement as before. I mean, obviously, unless C was equal to 0, but this is supposed to be a general case where C can be anything. The equality needs to be a true statement no matter what we do, or it wouldn't be equals. A very loose example, and let's say I wanted to turn this 7 into a 10 for whatever reason. In order to turn the 7 into a 10 by addition, I'm going to add 3 to this side. But in order to maintain this equality, I'm going to have to add 3 to this side as well. Whatever we do to one side, we got to do to the other side. So 7 plus 3 is 10. Sure, it can be 5 plus 2 plus 3 is 5, like that. This is still a true statement. Yeah, I'm not doing an equal sign here. This is just more for notes for our bookkeeping. We're going down in our steps. And this is what I found to be the best way to go about it. When you're doing these things on like homework assignments, you can be tempted to kind of use the entire notebook sheets of paper going along in a line all the way across like this to conserve paper. And as much as I can agree with that, I cannot agree with doing that for your math work. Here's why. Let's say I wanted to do this same example, 5 plus 2 equals 7. I'm going to put this equals sign in a red for the bad equals, because a lot of kids will be like, okay, 5 plus 2 equals 7, and then they'll just do like equals 5 plus 5 equals 10. They'll just kind of keep going in a line. If I were to just kind of hone in on this interim step here, this is not a true statement. So it's just really easy to get lost into like what you're doing. If you are determined to do it this way, instead of an equal sign here, do like an arrow to signify that you're moving on to the next step. But even then, I can't like notice at a glance what I've done. This is much more concise. This is really showing me that I specifically put a 3 on each side of the equal sign just to kind of remind myself that I'm doing this to both sides. The next one would obviously be subtraction, and this works very similarly. If we have an equality and we subtract the same thing from both sides, the equality is maintained. Again, we're not getting to like a definite answer. I must have gotten rid of it. Or we're not getting to a definite answer with each and every step that we do along the way. These are just tools that we'll be using to our advantage to get to what we want to do with variables. For an example, and I'm gonna subtract 3 from both sides. And you could do this if you wanted to. 10 minus 3 is 7. 5 minus 3 is 2. And then we didn't do anything to this over here, and the equality is maintained. This doesn't look like I'm... Okay, so like I could do 10 equals 10 and then subtract 3 from both sides. Yes, technically I've maintained the equality by doing this. But I don't know. This example over here is a little bit more dynamic. What's going on here is pretty obvious, but I'm including variables into this until we make sure we have all of these properties.